Hi everyone, in this video we are going to look at one-way ANOVA models. So let me type it out. It is one-way ANOVA, and as you may know, ANOVA is actually analysis of variance. And this analysis can actually tell you are there differences in different like in the mean values of different groups. For example, if you want to know the lifespan, the average lifespan of different dog breed, right? So you may want to do like each dog, you have the lifespan and you have their dog breed information, and then you can actually run a one-way ANOVA to check are there differences in different dog breeds in terms of their lifespan. So the example here we are going to use is called iris. So you can just run data iris, so that iris data is in your system. And you can also quickly run head function, which will type out like the first 6 rows of the data. So you can see we have sepal length, sepal width, pedal width, and we also have species. So if you want to run a quick summary of the data set, you can do summary function, which gives you the idea about, okay, what's the minimum, what's the maximum of the sepal length, width, pedal length, width, and also what species we are looking at. So these values here, you can see we have 50 observations for each species. So one quick question maybe we can check on is, are there differences in sepal length for different species? So more specifically, you may want to know, are there differences in the mean sepal length for different species? So from the data we collected, we have 50 observations for each species. But we are actually making an inference to talk about in general, what's the average difference? Are there average differences for these 3 species? So this is our question, and we are actually testing on, let me type it out. So we are testing on the null hypothesis. There are no differences in the mean sepal length. So that's what we are checking on against the alternative hypothesis here is there are some differences. So there are no difference versus there are some differences. So some differences mean it can be these 2 species, they have differences. It can be these 2, or it can be all 3 of them. So this is our question. And the first thing we are going to do is called exploratory data analysis. We want to visualize the data to explore what we are saying, like what we can get from by drawing graphs, by taking a first look at the data. So you can see we can actually draw a box plot, a very simple box plot using this sepal length, which is our target, according to the species, which is our categorical variable, and our data set is called iris. So you can actually draw that box plot to have a first look. So you can see, if you zoom that picture, you can see it better. And you can see for these 3 species, the last one has the highest median value. The middle black bold line is the median. So you can see the median values are having a very big difference. And the first species on the very left has a very large difference comparing with the last box plot on the very right. So that's our initial impression. And you can also calculate, so this is our side-by-side box plot, which gives you a good visual of what's happening. You can also calculate the mean and standard deviation for each species, which you can use a function called aggregate. So you can do the same thing. I'm just copying this because they are using the same syntax. So you're using sample length versus species, and you can calculate the mean value of each species. So if you run that, oh, I forgot to copy the letter S. So you can see object IRE not found. So that gives you the idea, okay, add that S in. So I run that aggregate function and I'm seeing the sample length. This one is only 5, this one is 5.9, and this one is the largest, which is 6.6 roughly. So that also gives you a second idea. Okay, there are some differences, but we're not sure if the differences are significant or not, right? So by now, you can also run the standard deviation by copying the whole line and changing that mean into standard deviation. So you can see the variation in the data, and the third species has the largest variation. This one has the smallest variation. So this gives you the numerical idea of exploring the data. So now we have finished EDA, and we are going to run our model, which is the ANOVA model, and which can be done by using AOV function. And the same thing, we use the numerical variable versus the species. I don't like typing it out, so I often just double click and paste it there. So if you run this and let data equals iris, and that gives you your ANOVA model. And you can see this is a very brief result. Most likely I would give it a name and I run the summary. So if I run this line 16 and then I run this summary function of that model, you can see this is the result of the ANOVA model. We have 3 species, which gives us the degree of freedom of 2. And we have the p-value. So ANOVA model is like an f-test. So you're doing an f-test with a corresponding p-value and with 3 stars. So which means the test is very significant. So if you run to the result, you would conclude the ANOVA model, some people also call it the ANOVA test, gives us a f-value 119.3 and p-value almost 0. So you can type it almost 0, or you can type it less than 0.001, which means it is very significant. So the result here is that we reject the null hypothesis. And we conclude there are. So we reject this one and we are concluding the other one. So there are some differences in the mean sample length for different species. And that's it. So you can see we have done everything for the ANOVA model. We started with looking at the data. We then did our EDA by drawing a box plot and did some calculations. And then we ran the model and we didn't forget summarizing our result. So that's about it. That's that would be a good example for you to learn about ANOVA model, and you can actually just mimic everything for any other data sets solving a similar problem. Thank you.